Do the law of sines. And you remember from geometry that you had angle, angle, side, angle, side, angle, side, 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 and side, angle, side. You guys remember that from geometry? Well, in geometry, you learned that that gave you one triangle. And you do you guys remember law of sines from last year in geometry a little bit? Well, let's go ahead and write this down, that this guarantees one triangle. Let's also draw a picture of a triangle. We'll label it triangle ABC. And remember, across from angle A is side A, across from angle B is side B, and across from angle C is side C. So the law of sine says that you can take any two of these ratios, side A over sine of angle A equals side B over sine of angle B, or side C over sine of angle C. So let's look at example 1. It says given triangle ABC with angle C is 102 degrees, angle B is 28 degrees, and we have side B is 27 degrees. Find the measures of the remaining angle and sides. So you don't necessarily have to draw it to scale, but if you can, that's wonderful. Angle C is obtuse, it's greater than 90 degrees. Then it wouldn't matter where you're putting B, just make sure you're labeling it 28 degrees. Side B is 27 feet. What I recommend that you do when you're dealing with law of sines, and then when we move to law of cosines, identify what type of triangle you have. Angle, angle, side, angle, side, angle, side, 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 and so on. So right now, what type of triangle do I have with the given information? Good job. It's angle, angle, side. Good news is that guarantees one triangle, no worries. Which side do I need to find so that I can use the law of sines? Side C. So what we're going to do is we're going to put C over the sine of 102 degrees equals 27 over the sine of 28 degrees. This is a proportion. We can solve a proportion by cross multiplying. So I have C times the sine, 28 degrees, equals 27 times the sine of 102 degrees. What's nice about this is you could do a straight calculator entry if we divide by sine 28 degrees. Check your mode. My angles are in degrees, so I want to be in degree mode. So on your calculator, you can take 27 times sine 102 degrees divided by sine 28 degrees. I rounded one decimal place. Please circle or box all the information that you're finding. I got 56.3. If there are units given, make sure your answers include units. So now, I can find angle A. How do I find angle A? Isaac, how do you find angle A?
Would you square both of them, but since 56.3 is a hypotenuse, then you would subtract the square root, or I don't know what it's called, 27 square root.
You're thinking of a right triangle, right? Pythagorean theorem works if you have a right triangle. Yeah, Katie?
180 minus 102 minus 28.
Good. Add the two angles and subtract from 180. I think you were thinking of the side there, Isaac. So go ahead and do that for me. Add 102 and 28, subtract from 180. I'm getting angle A is 50 degrees. All right, now we need to find side A. So I'm going to put A over the sine of 50 degrees equals, and then I'm going to use the 27 over the sine of 28 degrees. That is a 28 there. Okay, go ahead and cross multiply. You're solving a proportion. I rounded again to the nearest tenth, and I got 44.1 feet. So when you are trying to solve a triangle, draw the triangle, identify the parts, identify what type of triangle you have. Whether it's angle, angle, side, angle, side, angle, side, side, side. And then you can go with your law of sines. Okay, any questions on that one? Okay, let's look at example 2. It says, given a triangle ABC with sides A is 22 meters, B is 12 meters, and angle A is 42 degrees. Find the measures of the remaining angles and sides. So let's draw a triangle. Angle A was given as 42 degrees. Side A is 22. Side B is 12. We talked about this earlier in the week. Geometry teachers often say that you cannot do the donkey or the side angle case. And the only reason why they say that is in geometry we oftentimes don't have enough tools in our tool belt to do that. Do you guys remember last year, did Mr. Nisley do 2 cases? The 2 triangles, the no triangle? Does that sound familiar at all? No? Okay. All right. Well, here's the deal. We're going to get, if you have side angle, there are 2 cases. Case 1, if the missing angle is smaller than the given angle, you're going to get 1 triangle. And you work through it with law of sines, no problems. Case 2, if the missing angle is larger than the given angle, then you have either no triangle or 2 triangles. So when you actually go to work it, either it's in case 2, either it's going to work or it's not going to work. So let's go ahead and see which case we have. The given angle in this problem is angle A. Which angle is the missing angle? Is it B or C? It's B because we have its opposite side. We can't say that C is the missing angle because we don't have enough information to determine. So from geometry, you should remember that across from a larger angle is a larger side. So across from angle A is 42 degrees, and it has across from 42 degrees is a side that's 22. If the side across from B is 12, what can you tell about angle B? Is it bigger or smaller?
Smaller.
It's smaller. So this one is case 1. And we're going to get 1 triangle. So let's go ahead and do this one. I'm going to find angle B. And what I like to do, your law of sines, and we had that in the notes on my first slide, is you can flip the fractions. So you can put sine B over side B equals sine A over side A, and it's still an equivalent form for law of sines. So I'm going to have this equals the sine of 42 degrees over 22. Now this is still a proportion. I'll cross multiply. So I have 22 sine B equals 12 sine 42 degrees. What's different about this proportion than in example 1?
You can't just divide to cancel out the signs.
Right. Why? What are we looking for in example 2 that's different from example 1? Aren't we trying to find the angle now instead of the side? So you're right, I can divide by 22 to both sides, but that's still not going to give me the angle. So your mode should still be in degree mode, so we're going to take 12 times the sine of 42, and let's go ahead and divide by 22. And that's giving me the sine of B equals 0.365. Now what do I need to do in order to find angle B? How do you undo the sine function? Inverse sine, okay? So we're going to do inverse sine, and you can do second answer. And so angle B is 21.4 degrees. Please make sure as we're doing all this work to circle or box your answers, because it'll be hard to find your information. So now we can find angle C by just adding 42 degrees plus 21.4 degrees and subtract from 180. So angle C is 116.6 degrees. Then the only other thing we need to find is side C. So I have C over the sine of 116.6 degrees equals 22 over the sine of 42 degrees. I want you to notice in this example, with my first law of sines, I had sine B on the top because that's what was unknown. In the second one, my side C was the unknown, and so I flipped it. I flip it to my purpose that I have. It doesn't matter though. I mean, I could always put the side on top every time and it'll still work. So let's cross multiply and divide. You could actually do 22 sine 116.6. Press enter. Divided by sine 42. And I'm getting C is 29.4, and that's meters. So whenever units are given in the problem, include units in your answer. All right, any questions on this one? All right, now let's go ahead and look at example 3. It says you're given a triangle ABC. It says angle B is 65 degrees. Side A is 30 inches. Side B is 20 inches. So draw a diagram of the situation that you have. Next, determine what type of triangle. Do you have side, 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 angle, angle, side? In this case, we have side, side, angle. So this is the donkey. So all the other cases, you get one triangle, no worries. But when you have the donkey, you've got to be concerned. So we have, is it case 1 or case 2? Angle A is the missing angle. And what do I know about angle A?
It's larger than angle B.
It's larger, so this is actually case 2. Case 2 is no triangle or two triangles. So let's start working it out. I'm going to do the sine of angle A over 30 equals the sine of 65 degrees over 20. So I'm going to take 30 times the sine 65 divided by 20. And I have the sine of A is 1.359. Right here, if I have my thinking cap on, I should notice that the sine of A oscillates between -1 and +1. So there's no way I can get the sine of an angle to spit out 1.359. So let's suppose we go motoring along with our procedures and we do inverse sine of 1.359. The calculator gives me an error. So what this means is there's no triangle. It's impossible. All right, let's look at the next one. Example 4. It says solve the triangle ABC, and we have angle A is 40 degrees, side A is 13, side B is 16. So again, draw the picture, determine what type of triangle you have. This again is side-side angle, which is the donkey case. And then we need to determine, is it case 1 or case 2? Well, angle B is the missing angle, and it's larger. So this is case 2, either no triangle or 2 triangles. So just like in example 3, side-side angle, the missing angle was larger, it didn't work, so it was no triangle. In this case, guess what? It's going to work, and we're going to see how you do 2 triangles. So I'm going to get the sine of B over 16 equals the sine of 40 degrees over 13. This is a proportion, so we're going to cross multiply and divide. So I take 16 sine 40. I'm going to go ahead and divide it by 13. So I have the sine of B is 0.791. And that's good. When you look at sine B equals 0.791, I know the graph of the sine function oscillates the range between -1 and 1, so this is okay. And I'm getting angle B is to be 52.3 degrees. So it worked. That means when it's side-side angle, case 2, and it works, you actually have 2 triangles. And something I want to point out to you is, how do you get 2 triangles? Well, if you remember, all students take calculus. If I have a reference angle in the first quadrant of 52.3 degrees, there's actually another place in the second quadrant that has a reference angle of 52.3 degrees, that when I take the sine of that angle, it's still going to give me a positive 0.791. So let's take 180 minus 52.3, and here would be my second triangle. This angle B is 180 minus 52.3 degrees, which is 127.7 degrees. So what ends up happening is the given information is always given. In this case, angle A is 40 degrees, side A is 13, side B is 16. Given information stays given. But then the remainder of what you're finding changes based on whether you're in your first triangle or your second triangle. So if I want to find angle C in my second triangle, I take 40 plus 127.7, add those together, subtract from 180. So angle C is now 12.3 degrees. In my first triangle, I would take 40 plus 52.3 degrees and subtract that from 180, and I get 87.7 degrees. Now, what's the only thing missing in both triangles? Side C. So I'm going to do side C over sine 12.3 degrees equals the sine of 40 degrees over 13. So I'm going to cross multiply and divide. And I'm getting C is 4.3 centimeters over here. Coming back here, side C in the first triangle over the sine of 87.7 degrees equals 13 over sine 40 degrees. You cross multiply and divide. And I'm getting C is 20.2 centimeters. Okay? Yeah, John?
On the proportion after you divide, how do you enter into the calculator?
On which part? Over
Any
here?
of them.
So I would take, oops, did I write that down wrong? Wait a minute, John. That one's upside down. Hold on. Because remember, you do have to be consistent. This would be side 13 over, is that what bothered you? No, I just flubbed up on how I
Yeah,
wrote that.
like, how do you put it into the calculator?
Okay, so you're going to put 13 times sine 12.3 degrees and press enter.
Negative sign or just regular sign?
Just regular sign, not inverse sign.
Okay, good question. The only time you're going to do that inverse sign is when you're trying to find the angle inside.
Okay.
In this case, I'm not trying to find the angle, I'm actually doing the sine of 12.3. So there's no inverse sign involved. So I would do 13 times sine 12.3, enter, divided by sine 40 degrees. Good question. The only time you do inverse sign is if you're trying to undo the sine function to find the angle inside.
What do you divide by after you do 13 sine 12.3?
Okay, so here, I skipped that step. Let me put it here for you. So that's 13 sine 12.3 degrees equals C times the sine of 40. And then you would actually have to divide both sides by sine 40. So you take 13 times sine 12.3 degrees, press enter, divided by sine 40 degrees. Okay, so you're solving a proportion. Okay? All right, area of a triangle. The area of any triangle, note, it's not necessarily a right triangle, is given by 1/2 the product of the lengths of two sides times the sine of their included angle. This is actually side, angle, side. So let me draw a triangle here for you. And what we're saying is, if you have side B and C and angle A, you can use the first row. Again, if you have side B, C, and the angle in between, that's side, angle, side, you would use the first one. And if you had side AB and angle C, you would use the second one. And if you had side AC and angle B, you would use the third one. So let's look at example 5. It says, find the area of the triangle given the following information. It's just a really good idea to always draw the information that you have. So when I do this, do you notice that you have side, angle, side? So the area is 1/2 10 times 15 times the sine of 55 degrees. I want to remind you that area equals 1/2 the base times height is only where you have a perpendicular height. This area formula then opens it up to, what if you can't find the perpendicular height? Then trigonometry gives you another avenue in order to do that. So this one you can enter straight into your calculator. Remember, area has units squared. So this is 61.4 meters squared. Any questions on example 5? All right, last one. Example 6. You are setting up a triangular flower garden in your backyard. So let's draw a triangular flower garden. If you lay off lengths of 15 feet and 11 feet with a 62-degree angle in between, what's the area of the garden? So as long as it's side, angle, side, we can use area is 1/2 the product of the two sides times the sine of that included angle. Okay, pretty simple. So go ahead and use your calculators. We have been predominantly in degree mode, but it's a good idea to always check your mode. Remember your units, and I'm getting 72.8 feet squared.